If you pull apart almost any piece of modern hardware, you'll find a set of extremely powerful permanent magnets. These are made from rare earth elements, and they are the invisible forces that make our entire technological world snap together. We rely on these metals for everything, from the vibration motor in your smartphone to the heavy-duty generators inside wind turbines. But the stakes peak in the defense sector. A single F-35 strike fighter requires over 900 pounds of rare earth materials to operate its targeting systems, radar, and control surfaces. This map shows where these elements are found across the globe, which is pretty much everywhere. Rare earths are actually quite abundant in the Earth's crust, but if you look at where they are processed and refined, almost the entire supply chain is bottlenecked inside a single country. China currently controls roughly 90% of the world's rare earth processing capacity. That processing dominance is actively used as diplomatic leverage. Over the past decade, and escalating severely in 2026, Beijing has weaponized its market share by tightening export controls. When territorial or trade disputes flare up, international manufacturers suddenly find their critical material pipelines choked off. This vulnerability has triggered a hard countdown. The U.S. Department of Defense has mandated that by January 2027, Chinese rare earth materials must be completely eliminated from the American military supply chain. The West is now in a desperate sprint to build an entirely independent supply network from scratch. But breaking a superpower's monopoly requires paying a steep, three-part price. The first cost is time. Pulling raw rare earth ore out of the ground is a relatively straightforward process. Allied nations like Australia and the United States already have large-scale mining operations actively digging the dirt. The actual roadblock hits during midstream separation. Taking that mixed ore and isolating individual elements like neodymium requires highly specialized, chemically intensive facilities. A single medium-scale processing plant costs hundreds of millions of dollars and takes up to 7 years to build. To force these facilities into existence, the Pentagon and allied governments are stepping directly into private markets. They are bypassing normal investment cycles, offering massive grants and taking direct equity stakes to fund domestic processing plants as fast as possible. But billions of dollars in government capital cannot alter construction timelines. Until those massive chemical facilities actually come online, Western manufacturing remains heavily exposed to sudden and crippling Chinese supply shocks. If we can't physically process enough rare earth metals right now, the second option is to design around it. Scientists are attempting to bypass these specific elements entirely. Look at this structural model. Instead of relying on a complex rare earth matrix, researchers synthesize permanent magnets using iron nitride. This technology swaps difficult-to-process metals for two of the most abundant elements on Earth, iron and nitrogen, while theoretically achieving an even stronger magnetic pull. Alongside new materials, there is a massive push to squeeze value out of the supply we already have. Facilities are using AI-monitored extraction techniques and shredding old consumer electronics to reclaim rare earth elements directly from urban e-waste. These laboratory breakthroughs map out a brilliant long-term escape route, but they are years away from mass commercial production. Manufacturers need raw materials on the assembly line today, forcing them to secure physical supply by any means necessary. That urgent need for immediate supply brings us to the third and highest cost. China built its processing dominance largely through decades of cheap labor and lax environmental oversight, leaving behind highly toxic radioactive waste lakes near its major mining hubs. Now, as other nations scramble to secure their own rare earth reserves, aggressive extraction operations are expanding into some of the world's most fragile ecosystems. We are seeing large-scale mining efforts encroach upon pristine environments like the Amazon basin and the grasslands of Mongolia. The search is extending to extreme frontiers. Japan recently launched a project to vacuum rare earth-rich mud directly from the ocean floor, operating roughly 6,000 meters beneath the surface of the Pacific. This creates a severe ecological paradox. In the rush to secure the exact materials needed to build green energy grids and fortify national defense, we risk causing a new wave of global environmental destruction, unless strict international standards are enforced across the board. This diagram illustrates how the global trade map is actually realigning. For decades, the entire world ran on just-in-time delivery, where the only goal was finding the absolute lowest price. But as that fragile system shatters, it is being replaced by isolated, heavily fortified regional trade blocs. We've entered a phase where supply chain security is more valuable than a low price tag. Companies and governments are now planning for resilience first, which means accepting that manufacturing costs might stay 10 to 30% higher just to ensure the assembly lines never stop. This shift changes the math for everything built next. It alters how we fund military hardware and how quickly we can realistically deploy the massive arrays of wind turbines needed for the energy transition. That is the independence trilemma. To break China's grip on these metals, the West has to endure higher financial costs, accelerate high-risk scientific innovation, and navigate a potential ecological disaster. Geopolitical independence is not a discount product. To secure the future of our technology and our defense, we finally have to accept the responsibility of getting our own hands dirty.